Hello everyone. Welcome to the e-learning space of data science for public policy. This video is brought to you by the DSPS Data Science and Policy Studies program under the Chinese University of Hong Kong. This video is supported by the CUHK Courseware Development Grant Scheme. Our topic for this video is about confidence interval. We're going to have a revision on statistical inference, confidence interval, and then it comes to the application part where we can look at some scatter plots. First of all, statistical inference is about inferring value of population parameter. A parameter is a number that describes a population distribution, such as mean or standard deviation. How do we make the statistical inference? We make the inference based on the number computed from the sample data. The number is called a statistic or a sample statistic. A random variable that is used to estimate the population parameter is called an estimator. If your estimator is a single number, then it is called a point estimate. And if your estimator is an interval, and then we call it as an interval estimate. Next, let's talk about confidence interval. So so a point estimate for the population mean mu is sample mean. So this is the point estimate. But if we want to make an interval estimate for the population mean mu, then we are going to make two values, a lower and an upper value, which the range covers the population mean mu. So this is called the confidence interval for the parameter mu. And depending on how we define alpha, then the confidence interval can be different. So in practice, if we define alpha as 0.05, then here 100 times 1 minus alpha would be 100 times 0.95, and therefore you will have a 95% confidence interval. So depending on different values of alpha, and look at the below formula, you can see that your set score is going to be different. Then in that case, your lower and your upper interval, the two values that defines your confidence interval would also be different. So next, let's go to the application part. So again, here we are going to use the Hong Kong visitor arrival sample data from the Hong Kong Tourism Board. So if you follow the link here, you can go to look for a publication that is called Visitor Arrival Statistics, and then you can download the data in either in PDF or Excel format. And after cleaning the data, today we're going to use two variables, which is a total VA, the total monthly total visitor arrivals in Hong Kong, and the total VA mainland China. So this is the monthly total visitor arrivals in Hong Kong from mainland China. So the time period covered, again, is going to be from January 2016 to December 2020. So if you have a look in the data set, it looks like this, where we have the two variables, total VA and total VA mainland China, and then we have the time variable, which is the month from January 2016 all the way to December 2020. So in Stata, what you have to do is first you have to import the Excel file I just showed you. So you have to set the path to be the path where you stored your Excel file. And after you successfully imported the Excel dataset into Stata, then next you have to do a type of code that is called TS set time. So TS refers to time series. So here you are setting the time variable in our Excel file in column A to be the time to let Stata recognize that this is the time variable. And then next, we are going to generate a variable. We are going to create a variable that is called period. And in period, there are three values. So the three values are normal times, extradition bill times, EBO times, and COVID-19 times. So if you're not sure how we should define these period, then you can look back to the previous descriptive statistics video where I explicitly talk about how to define and how to generate a new variable. And then to look at confidence interval, first here we are going to create another variable which is called mainland proportion. So we have to type gen, G-E-N, which means generate, a variable called mainland proportion. And this variable is defined as the total number of visitor arrivals from mainland China divided by the total visitor arrivals. So this is going to be a fraction or a value that is between 0 to 1. And then next, we have to type CI, which refers to confidence interval, and then means, and then the variable of interest. Right now, we're interested in this newly created mainland proportion variable. And first of all, we want to look at when period equals to 1 normal times. So you type this code, and then we have a small table here. And here we can see that during the normal times period, the average mainland proportion is 0.768663. So that means approximately 76.8 to 76.9% of the visitors are from mainland China. And then on the right, you can see the 95% interval for these mean, so which is 0.75989 to 0.777. So that means the confidence interval is also very close to the mean. So on average, slightly more than 75% of the visitors are from mainland China during period equals to 1. And then next, if we want to look at period equals to 2 eval times, then we just change the code for the period. So we define period as eval times instead. And again, here in the small table, we can see the mean is 0.770. And then the confidence interval is 0.751 to 0.789. So that means during the extradition bill times, still around pretty much the same, that more than 75% of the visitors are from mainland. So that means they're still coming as a visitor. And then when we change the period to 3 COVID-19 times, so here you can see the mainland proportion. The mean is 0.5399. So that means that it is just a 50-something% of the proportion of all the visitors are from mainland China. So about slightly more than half of the visitors are from mainland China. And then when you look at the right, we have the 95% confidence interval, which is from 0.4466 to 0.6333. So that means so the confidence interval is around 0.45 to 0.63. So that means if you're talking about the interval estimate, then during COVID-19 times, there is about 45% to 63% of the visitors are from mainland. So next, after we have looked at some numbers, then if you want to look at some graphical representation, so we're going to talk about how to plot a scatter plot. So a scatter plot is where you have all the data points or some of your data points located in a graphical manner, and then optionally you can choose to add a trend line by some fitted values. So here in the codes, you have to type, first of all, you have to type two-way. So two-way means you have two variables in your graph. And then in the first bracket, inside you have to indicate the plot type. So first you type scatter, which refers to scatter plot. And then next you have to define the y and x variable. So here we define the y variable as mainland proportion, and you can see on the y-axis it is going to be somewhere from 0.3 to 0.8, which is the number or the values of the mainland proportion. And then for x variable, we define it as time. So you can see the x-axis is all the months that we have. And then for the next bracket, you can see there is a code called lfitci. So this is the code where when you want fitted values appearing on your scatter plot, then you type this code. So here we are defining the fitted values to be the mainland proportion time, again the y and x value, if period equals to 1. So you can see that the fitted values, the red line, and also its 95% confidence interval, the two gray lines, they are they pass through January 2019, but they're not extending any further. So it is because that when we define the period equals to 1 normal times, is only up to May 2019. So therefore, you can see the fitted values here only covers period 1. So on the right, there is no more fitted values. And again, LFIT-CI refers, the L refers to linear. So here with the fitted values are assuming that there is linear relationship. And then next, here the only difference is we changed the LFIT-CI to be if period equals to 2 eBill times. So now you can see the fitted values and the 2 gray lines. They're only covering a shorter period of time, which is from June 2019 to January 2020. So you can see the red line only covers that corner. And please note that the data points are all the data points we have for mainland and mainland proportionate time. So only the fitted value is focusing on the period equals to 2. Here you can see the 95% confidence interval becomes wider, and also the data points have a smaller number. So we're only focusing on a few data points. And the next, if we change the code for the LFIT-CI to be period equals to 3 COVID-19 times, then here we are only focusing on data that is from February 2020 to December 2020. So first of all, you can see the data, the blue dots here dropped significantly. So before we're always seeing the blue dots, the data points are around 0.7 to 0.8. But now all of a sudden, the data points drop to be somewhere as low as below 0.3. So the fitted values that is focusing here, we can see the 95% confidence interval is much wider because the data itself is really scattered quite distant to each other. So lastly, let's talk about some policy implications. COVID-19 is the most significant reason for bringing the tourist industry to a standstill. The impact on mainland tourist arrivals has been particularly large. Mainland inbound tourism will likely remain subdued in the near term, but may begin to recover later when vaccination program in Hong Kong yield intended results. After the COVID-19 situations are put under control, mainland travelers' confidence could be restored by mass media campaigns. So this is the end for our video today. Thank you.